Today's lesson is on graphing proportional relationships. Let's break down what this means. Proportional relationships are multiplicative relationships. Like for every cup of flour, you need a cup of sugar. If we're going to be graphing these proportional relationships, we're going to be looking at them on a coordinate plane. A coordinate plane has a y-axis and an x-axis. It helps you compare things like time and cost. On the x-axis, we're going to put what's called our independent variable, and our y-axis is going to have our dependent variable. For example, how long I spend at a trampoline park is going to determine how much it's going to cost me to participate. Or how long I spend working, the time I spend working, is going to influence how much I am paid. All this means is that the x-axis kind of controls the y-axis. Here's our first example. A biker rides 18 miles in 1 hour. Graph the proportional relationship. Here's my coordinate plane. X-axis, y-axis. We first need to determine what we're comparing. In this scenario, we're comparing miles and hours. One of them is going to affect the other. How many hours the biker rides is going to affect how many miles he travels. I start by labeling my x-axis. If it already gave me 18 miles in 1 hour, I'm going to be counting by 1 hour increments. For labeling my y-axis, I could count by ones, but since it already told me it's 18 miles in 1 hour, I could just count by 18. After I'm done labeling my y-axis, it's time to actually graph the relationship because right now we just have our coordinate plane ready. Graphing the proportional relationship, I look at 18 miles and track it to 1 hour, and I put my first data point. Then that means he would be traveling about 36 miles in 2 hours, 54 miles in 3 hours, and you'll notice that this is forming a straight line. Well, if I could draw my line straight. This is a linear relationship. I know my graph is proportional because it's a straight line and it starts at 0, 0. AKA, if he bikes for 0 hours, he will travel 0 miles. Example 2, a Hulu membership is $8 per month. Graph the proportional relationship. And then it's asking, what do these 2 points represent on the graph? I start with my coordinate plane, my y-axis and my x-axis, and we're comparing dollars to months. Which one is going to affect the other? Well, how long you have or how many months you have Hulu is going to affect the cost or how much you pay. My problem already gave me my constant of proportionality or how much it is for one, my unit rate. So I can go ahead and mark my months in increments of 1. My cost, I'm going to look at what increment is changing so far. It's changing $8 per month. So although you could put this in increments of 2 or increments of 4, I could go ahead and choose to put this in increments of 8. When I graph my proportional relationship, I follow and plot each point individually. After 1 month, it's $8. After 2 months, it's $16. After 3 months, it's $24. After 4 months, $32. After 5 months, $40. And this is supposed to be a straight line. There we go. Now that my proportional relationship is graphed, I can determine what each of these points mean. 0, 0 is the origin right here. That means after 0 months, you'll pay $0 for a membership. The point 216 on the graph, when my x is 2 and my y is 16, this point represents that after 2 months, you will have paid $16 total for a membership. Here's one for you to try. Greg earned $27 in 3 hours. Graph the relationship. I have my x and my y-axis. I put the number of hours on my x-axis because it's my independent variable, and the amount of dollars on my y-axis because it's the dependent variable. They told us that Greg earned $27 in 3 hours, so they haven't given us the unit rate. We have to calculate it. 27 divided by 3 is $9 per hour. We can then fill in our y-axis based on our unit rate, $9 per hour. I graph my points, and it's going to look like this. Another option would have been to set it up this way. Let's say that you didn't calculate the unit rate, but you knew that after 3 hours it was $27. This graph still represents that relationship, so either one would be fine.